Hey, it's Ryan. So as part of our static analysis and assembly work, I wanted to give a quick overview, focusing on a few examples of the stack in memory. So we'll start with what the address space of an application should look like. So 32-bit applications will go from 0 down to this value in the lower left, which is the maximum value of a 32-bit number. Within here, we'll have program images, etc., DLLs, which are by default loaded at this address. We'll have the heap, which will contain dynamic memory allocated during execution. Then we have the stack, which we'll be focusing on this presentation. The important thing with it is that it grows from some start value towards 0. Then on the right, we have important registers. So the instruction pointer will contain the address of the next instruction to execute. The stack pointer will contain the address of the top of the stack. The base pointer will contain the address of the start of the stack frame. Then we have several general purpose registers, which will be used for temporary storage or for computations. There are also many other registers that we're not going to touch on here. So we'll start by going over a looping example. On the left, we have the current stack. So we have stack frames, and on top, we have the current frame. If we zoom into that, we'll start by looking at the EBP pointer, which is pointing towards this address. Above that, you have the stack pointer, which is pointing to the top of the stack. And you'll notice that these addresses are growing towards 0, or they're going down in value. And they're also of size 4, right? So the size 4 bytes is equal to the architecture, which is 32 bits. So if you look below EBP, directly below that, you have the return address. So when the function executes, or I'm sorry, when the function exits, the return address is the next instruction to execute. And below that, you have arguments that were passed into the function. So to access argument 1, you take EBP plus 8. Above EBP, you have local variables being used. So to access the first variable, you can take EBP minus 4. EBP during the function won't change, whereas ESP may change. So in the lower right-hand corner, we have registers and the data that they're going to contain during this sample. And then we also have memory addresses and the data that they will contain during this example. So the first address is just some data that's being passed in. You'll notice that this memory address corresponds to this stack address. So this is actually the data that's being passed in for argument 1. And then in the upper right, we have the instructions that we're going to execute. So the instruction pointer is pointing to this first instruction, and that instruction is a move. So we'll move the address at EBP plus 8 into the register EAX. So we'll just go ahead and execute that. We see that the instruction pointer has moved to the next instruction. And we also see that this register value EAX has changed. So just to review this real quick, what this is doing is EBP plus 8, so we already talked about that being the first argument. We're saying move the data stored at that address into EAX. So we take EBP plus 8, which is this address, and then we take the data stored at that address and move it into EAX. So we're taking the data stored here and moving it into the register here. So the next instruction we see is an add. So that means we are adding 4 to EAX and storing that back into EAX. So we'll execute that. We can see the instruction pointer has moved again, and the value stored at EAX has been incremented by 4. The next instruction is another move. This time we're taking the value stored in EAX and moving it to the address of EBP minus 4. So EBP minus 4 is going to be a local variable. So we take EBP 20108, subtract 4, 20104, and then we're going to store EAX at the address of 20104. So we'll execute this, and we can see we have a new memory address we're watching, 20104, and that's equal to 1238, or that same value that was in EAX. This next instruction is a common one, you'll see. It's used to initialize registers to 0, so we're just XORing a register with itself and storing it back in itself. So we execute this, and we see the register EBX is now stored, or is now set to 0. This next instruction is a compare instruction, so we're comparing EAX and EBX. In this case, we're really interested if they equal each other or not. So that's going to set the 0 flag. So we'll execute it, and then we'll talk about it. So 0 flag gets set to 0. If those two values had been equal, the 0 flag would be set to 1, right? So EAX minus EBX, if they were equal, would equal to 0, right? So 0 would be true. However, 0 flag is set to 0, so this next instruction, jump equals, right? This jump equals is saying if that compare, if those values were the same, we want to jump to this address, right? So this would say jump to 400113, which is down here. However, we know because the 0 flag is 0, that those two registers, or those two values really, were not the same. So we're just going to move to the next instruction. The next instruction is a subtraction. So we are subtracting 1 from EAX and then storing that back into EAX. Right, so here we see this changed. And then finally, we have an unconditional jump. So this is just saying, whenever we execute this instruction, jump back to this address, 400.104, which is actually back up here. We'll execute that, and we see the instruction pointer has moved back to that address. So what we have here is essentially a while loop. So while this value EAX, which is 1237 at the moment, is not equal to 0, decrement it by 1, and do the same thing over and over again. So this particular example isn't necessarily useful, but I hope it was helpful in kind of understanding some conditionals. The next thing we'll go over is calling a function. So similarly, we have a stack frame here, and we have the base pointer and then the stack pointer. And what we're going to do here is push some things onto the stack and then call a function. So when we push something onto the stack, what's going to happen is ESP is going to grow, so it's going to be decremented by 4, and then that value is going to be stored there. So we'll execute this first instruction, and we can see the ESP has been changed, and then we have argument 3 stored at this address. So if we look at this memory address, we can see the value from EAX3 is now stored here. The next instruction will do something similar, except that we'll just push a constant 0 onto the stack. Same thing, we can see ESP has been moved, and we now have the value 0 stored at this stack address. So this next instruction is pretty common. This is just pushing a address of a constant string. So there's a string hello stored somewhere in memory, and this offset str is just kind of like a variable for that address. So we execute that, and we can see again the stack pointer is moved, argument 1 is stored here, and argument 1 is an address of a string. Then finally, we're going to call this function. So we've set up the stack by pushing 3 arguments, and now we're going to call it. So this call function is going to store the return address on the stack, and then it's going to set EIP to the address of this function. So in this example, function is somewhere farther down in this memory, so it's just going to move EIP to point down there. Right, so we now have the stack pointer was moved again, and the return address was stored at that value. Right, so 200F8, we have that next instruction 40010B to execute. So once function A exits, this return value will be popped and executed. Okay, so that's it. I hope this was helpful. Thanks.